conceptual example 5.5 is an example to understand more on the terms tension or on the terms force called tension. Tension here you will find as the connector between the cars here. So train cars are connected by couplers which are under tension. So they are the connector. When locomotive pulls the train, so this is the locomotive, the A, the main train which has the ability or under power, has its own power with a motor to pull the rest of the train. So here in the picture we have A, B, C. So A is the locomotive, B and C are the trains at the back. Now imagine you are on a train speeding up. So acceleration and speeding up represent that the V keep changing. So as you move through from train, from the locomotive and to the next train and to the last car here, train cars, measuring tension in each of the connector here, does the tension vary, increase, decrease or stays the same? And what if it was brake, meaning that the acceleration turns to be decelerate and the coupler would be under compression? How does this compression vary from locomotive to the last one? Now, in the case that it's speeding up, so we find that tension would be the largest here, from the front to the back. Why? Because common sense as well tell us that A had to pull B and C, while B had to pull only C. Okay, understand? So how much your train at the back? What are objects at your back that you need to pull? So that's the reason why tension would be the largest between A and B, right? And in the case that it's the other way around, then you will find that the whole idea just flip to car, changes. So when it's decelerating, the coupler connecting to the first car must apply a larger force to slow down the rest, but the final coupler must apply a force large enough to slow down the last car. Example 5.6, the runaway car. Now in this example, we will find and note that the resultant force along the motion will be together with an acceleration. So in this example, you were given a car placed on a frictionless surface and without having its handbrake pull up, maknanya without handbrake, you'll find that the car run away. So how does the expression or forces acted on this car? What are the forces? So a car on mass M is on IC driveway, inclined at an angle theta as in figure as such. Find the acceleration of the car provided that it's frictionless, right? Now, let us analyze what are forces, the main forces that acted on this particular car. There is only two forces. Number one, the gravitational force, which is mg. This is number one. Okay. And number two, because it resides its own surface, you will find that there is a normal force. If you remember the definition of the normal force, as long as an object exerts force or how hard an object press onto a surface. So now, question that you must ask yourself, does this car press onto the surface of this road? So the answer, yes, right? So what are the direction? What is the direction? Out and perpendicular with the surface. So something like this. And this would be noted as N. So this is the one and this is the one. Now, our task, in order to find the direction or in order to simplify and get the acceleration, now we start with understand our common sense. In which direction is the motion? The motion will occur along the driveway. And for that, that will be along x-axis. So you are to redefine your x direction. So your x direction now is the inclined plane as such. Now, so you will find that normal force lies parallel with the y-axis, Hence, it's purely y. It's purely y direction. So don't bother about this one. This is already on y. So it's already a y component lah, in short. Okay. However, mg does not reside on any. So we have to open up to its component. So here, if this is how x looks like, perpendicularly, that will be how y looks like, which is this. So y is on the normal is on the y. And hence, still remember the previous tips, open to the nearest x and the nearest y. So this is the nearest x. This is the nearest x. So this is mg something, and this is perpendicularly which would be with some angle. Alright, now let's look in terms of the angle. Since, okay, the angle of the bank or angle of the driveway, okay, or incline, all the terms, incline, driveway, incline, right, bank curve. Okay, these are all represent the same idea, that it's not on a horizontal surface. In fact, it's on a certain elevated angle. So if this is the angle, then you will find that the angle is similar to this one. Now, still remember our technique? This particular component is just next to the original hypotenuse, and therefore we are using mg cos theta. And while this one, okay, since we are using this angle, and mg sin theta. Okay, mg sin theta. Now let's just play around. Let's just put numbers here. So 30 degree. So you will find that this is a product of mg cos 30 degree, and here is mg sin 30 degree. Now you might get confused. What mg? It's the mass of the car. It's the weight of the car. Okay, mg is the weight of the car. M is mass of the car. Right? Now, in order to find acceleration, hence, we are going to more and analyze, look again closely along the x-axis, because that's where acceleration occurs. And since there is an acceleration, that is the reason why we jot down as net force equivalent to ma, however, x direction, right? And what are force along x direction? Mg sin theta. This is it. Mg sin theta. So mg sin theta. So as we simplify mg sin theta, you will find that A is equivalent to g sin theta. So thus, if you simplify, you will find that you can cancel out m, mass, and arriving with this one, g sin theta. Surprisingly, acceleration can be calculated without even knowing the mass of the car, independent mass of the car, right? However, it depends only on the angle. So acceleration of the car, provided there is no friction, is just dependent on the g value and angle, right? Now, how about the in the y direction? Okay, well, for this case, the y direction is not being used in any means. So you just figure out, they will provide you only the normal force. So as you simplify, the normal force can be calculated and arriving with mg cos theta. Okay, let's look at the next question. Suppose the car is released from rest at the top of the incline. So you find that the U is 0. This is to represent that the concept U. And the distance from the car front bumper to the bottom of the incline is D. How long? How long? So the question is asking you T. Now, how to put it into words? Remember the kinematic expression delta X ut plus half AT squared. So this is the expression that you are going to use. However, this is 0. Why? Because it starts from rest. So the expression as you simplify turns out that if delta X is being replaced with a symbol of D as requested, hence you can solve and rearrange the expression into this version. Now, I'm going to give you an additional example very similar to the previous one. However, it comes together with a value, with a few values. For instance, this is the very same car and given here that the angle is 20 degree. So determine the acceleration of the car provided that there is no friction. That's number 1. Right. So let's start. So if you recall, the net force along the displacement is just mg sin theta. How do we know? This figure from the free body diagram. So mg sin theta. And what's next? Let's do the substitution. So how did we substitute? We, number 1, simplified the expression. So A is g sin theta and sin theta is 20, arriving with 3.35 meter per second. Now, what about the B? If the length of the driveway is 25 meter and the car starts from rest at the top, how long does it take to travel to the bottom? Right. Now, to reach the bottom, okay, remember the kinematic expression that you have seen earlier. Kinematic expression. So, what is the expression involved? So, delta X ut plus half AT squared. Turns out in this question, if it starts from rest, and that's the reason this is a zero product. So leaving only half AT squared. So A is the answer that you have seen earlier, and now you can calculate what will be the time required or time taken for the car to reach the bottom, which is here, somewhere here, down here. What is the car speed at the bottom? Now, let's just go back to the kinematic once again. So, the kinematic expression that we are looking at is V U plus AT. And this is 0. U is 0. How about A? 3.35. Okay, 3.35. Alright, and T is the value that you have calculated earlier. And arriving with this 12.9 meter per second. Example 5.7. One block pushes another. Now, the aim of this example is to allow you to understand number 1, free body diagram. Number 2, to enhance your understanding regarding normal force. Okay, normal force. Now, in this topic, in this example, you will find that normal force here will not be written as normal force, but rather another symbol. So, let's now have a look at the question. Now, there are two blocks here, M1 and M2. M1 is larger, so you can see that M1 in terms of the size drawn as well is larger. Both placed in contact with each other, no friction, on flat surface, horizontal, and a constant horizontal. Constant represent a single value applied to M1 as shown. Find magnitude, acceleration number 1 is the key, and system. Okay, when it says system, it represents that what will be acceleration for both. So S together, they are a system. Now, first and foremost, we understand or conceptualize or rational that since they are in contact, touching one another, hence they should have the same acceleration. Okay, they should have the same acceleration. So that's the logical view. On the other hand, so since we are looking at a system, so this is the system, and hence the way we write the expression, okay, net force should be equivalent to ma. So the generic expression that from Newton's second law says that net force is equivalent to ma. However, since the question is asking for system, and hence we are to include both mass. So M1, M2. So that's the reason why the expression turned into such. Alright, let's look at question B. Determine magnitude value, contact force in between the two blocks. Alright, why all of a sudden there is a term called contact force here? Now, this contact force is not something unusual or new term. Actually, it's very much similar to one you have seen earlier, which is normal force. In what sense? If you remember, I did mention that another term used to describe what is normal force is press. Okay. Now, assume that mass 1 and mass 2 are your hands in such figure. Okay. So, try to do this. Okay. Hold your both hands similar as the figure. Now, press onto one another. Okay. Press onto one another. You will find, you feel that amount of pressing onto one another. And because of the pressing, arise the force which would be something like this. Okay, one press onto the other, you will find that your left hand will be pressing, or pushing, I should say, onto the right hand. Onto the right hand. Right, this one, press onto this one. So, you get this one. So notice or not, the right hand will experience a pressing in the direction to the right. It's just that rather than using N, we're not using N because N will make more confusion because we tend to go with the horizontal surface or inclined surface, and here it's the surface between the two blocks. Right? Another way to understand is, you can see that they have the same value, same symbol, but in opposite direction, same symbol. So, amount of force are equivalent to one another. However, acted in different direction because acted on different mass 1 and mass 2. Or in this case, acted on different hands. Alright? Now, next thing that you need to note is the subscript use 2 on 1 and 1 on 2. 1 exert force on 2, and that's the reason why goes to the right, and 2 exert force on 1 going to the left. Another common sense that you can make up is, the direction is to the left. Object is supposedly experience an acceleration to the right, or motion is to the right. So, this particular box acts like a hindrance ataupun obstacle. Kalau obstacle kan dia menghalang. So, object supposed to be moving to the right. Menghalang is moving, force should be applied in the opposite direction. So, P21 memang similar to that idea. Is hindering, melawan, obstacle to the left. Right? So, this particular free body diagram makes sense then. But finally, now that we are able to draw free body diagram, and not to forget that the direction of normal force, wake of M1, again similar to the second object, second mass, its own wake and its normal force perpendicular. Another reason again why we are not using P as N, okay, so notice that N is here and then another N, we might get more confused. Alright, now going to solve, what we did is we are going to only look at one time individually. For instance, given here is on figure C, So this is figure C, yeah. So this is figure C. Okay, figure C. Now looking at figure C in the x direction, what is forces? So we find that the only single force here is just P12, and that's the reason why they write it as P12 singularly. And this expression, a generic expression that you have seen earlier, is Newton's second law. Newton's second law says that resultant force is equivalent to MA, and A is in the x direction. And what is the mass that you are looking at? M2. So you write M2. So it's all about ni tengah tengok apa? M2, alright. So M2 is the resultant. And then look at the free body diagram. What is or are forces acted along this direction of acceleration? It's P12. So that's how you arrive with this expression. Okay. And finally, you will find that they take this value of M and force and substitute to present the idea of the whole ideas, okay, the whole ideas. But overall, it's kind of enough that you ended here, and remember that acceleration is from this value, okay. Now, if we just now look at M2, what if we look at M1, mass 1? So mass 1 would be looking at figure B. So figure B, based on figure B, we find that forces in the x direction are F and also P21. So how do we substitute into Newton's second law? Then becomes to the right. It's to the right and this is left. So that's why it's a negative product. And when we simplify, it's equivalent to M1AX. Now notice, because we are looking at 1. Mass 1. And from here, okay, from both expression, we need to look again at our interest. So let's say that we are interested with getting P12. Okay, would it be sufficient by looking at this expression? Yes, as well. You notice that you have the mass. You notice as well you have calculated the acceleration. So yeah, you can calculate by using this expression. Okay, this expression, provided that you have the force and mass individually. Or perhaps by using this expression, because force might be given. Okay, so any of this expression is ample enough to solve the value of P12. Any, pilih, choose. Yeah, but here the main concern is for you to understand how to draw the free body diagram. Okay, example 5.8, weighing a fish in an elevator. Right? So, the question, a person weighs a fish of mass M on a spring scale attached to the ceiling of an elevator as in figure. A, show that if the elevator accelerates either upwards or downwards, the spring scale gives a reading that is different from the weight of the fish. Now, the A question is meant to get the expression. Kita macam nak dapatkan equation. Alright. B, however, this question give you with numbers. So, later after we done with this, we are going to substitute the expression here. Okay, in the case, okay, we need to choose a situation. The situation is the object is moving in the direction vertical. So, therefore, applying Newton's law, is it Newton 1, Newton 2, Newton 3, would be in the direction of Y. Okay, in this case, it's quite direct that a system here given it's accelerating. So it's accelerating. So indeed we are looking at Newton's second law. So writing Newton's second law, the proper one should be Newton net force Y is equivalent to MA in the Y direction. However, these two equations can be divided into two. Either putting A as negative AY or positive AY. So as our understanding, positive represent getting upward, accelerating upward, negative accelerating downward. Now, look again at the free body diagram. Okay. Indeed, the wake is always, indeed, wajib. Wajib. When any object comes with a mass, the direction of the wake directed downward. Okay. So here is the downward. Now, attached to it was some sort of hooks where the hook is internally inside here attached to a spring where the spring is equal to the tension. Okay, ketegangan spring tersebut. And for that, drawing becomes another force upwards resembling the tension. Now, notice the acceleration, okay, vector is drawn here to indicate the common sense of the system. Okay, common sense, accelerating in which direction. Alright, in the case that it's accelerating upwards, then this expression would be written as T minus mg equivalent to positive ma in the y direction. Now, can I not write AY? Yes, you may. It's just that you need to understand, common or rationalize your understanding. Why do you write Y? Because to indicate that the system is accelerating in the Y direction. Okay, so that you understand. It's just to let you understand. Okay, the direction. So this is the first expression, okay? And from this expression, you are going to rearrange and get the tension. So as you simplify, you will arrive with MA plus MG, MA plus MG, which is this one, right? MA plus MG. The rest is just factorization. So you can actually leave your answer as this one and later on just substitute number, okay? Now, how about if it's decelerating or accelerating downwards? In this case, just reverse the process. T minus mg equivalent to negative ma. Alright? And that's, yeah, okay. So, it's just a modification to the A, symbol A here. Either you write with a negative value or a positive value. Alright? So coming back to what's given by the book, okay, like I did mention earlier, if you are being asked to calculate the scale reading, in this case scale reading represent the tension, the next one, the tension, so you may leave your expression as such, okay, except that the second expression should be T equivalent to negative MAY plus MG, okay, this is optional. Alright, nevertheless, so when acceleration now is given as a 2, okay, either you go by the technique given by the book or go with the basic that you have seen earlier. Substitute the value of A accordingly, okay, and you will arrive with the given answer. So, in conclusion, when it accelerating upwards, similar to the previous normal force concept earlier, you find the value of the tension slightly larger, and going downwards slightly less. Okay, so if you buy a fish in buy weight in an elevator, you might as well make sure that the elevator is either at rest or accelerating downwards. Okay. Now, another issue that you might ask is, I'm confused, madam. Should I jot down G as negative 9.8 or positive 9.8? Alright, okay. Now, first and foremost, look at how they substitute. Okay, based on the expression, this is the G. Okay, this is the G. Based on the expression, okay, based on the expression, this is the G. Without negative. Why, madam? Because negative is already here. When you substitute and making the expression, creating the expression, you have concluded the direction. You have concluded that the G is negative 9.8. This, okay? So do not overdo it, double do it. I would say double do it lah, because the direction is already in the figure, and then you masuk equation, and then finally substitute again. Negative don't. Okay. So negative 9.8 is already in figure. In figure. It was translated dalam bentuk gambar. So there is no need for you to again substitute that G is negative 9.8. So in conclusion, it's only in the free fall that G is negative 9.8. From here onwards, so you will find either 9.8 or 9.81. Both is correct. Meter per second. Alright, in this example 5.9, we call it Artwood machine. This is Artwood machine. It's a machine actually called Artwood. Alright, nevertheless, the aim for this example is for us to derive expression untuk dapatkan equation. And for that, we need to learn how to draw free body diagram. Okay, let's start. Two objects, unequal mass. When they are unequal, therefore it's unbalanced. Okay. However, the pulley is negligible in mass, including the string. String pun tak ada mass. So, remember, I did mention that when do you have to apply mg? When the object has mass. That's the reason why in this question, we put it as frictionless, no friction, and also negligible mass for the pulley and including the string. Alright, the aim of this experiment or this setting is usually to determine the value of G by measuring acceleration of the object. Alright, the question, please find or determine acceleration of the two objects and their tension. Alright, number 1. This is the same string. Okay, ambil tali, okay, buat macam setting ni, you will find that it's the same string. Because that they are the same string, so number 1, same string, maka same T value. So same T value, maka we will use the same symbol, T saja, tak ada T1, T2. Okay, so same T. Number 2, okay, you need to identify acceleration direction for both. Okay. Alright. And number 3. Okay. Number 3. They have same acceleration. Okay, let's start with number 3. Why did they have the same acceleration? Common sense is, if let's say you are pulling your little brother and start running, okay, and in fact it's your little brother is not even running, dragging him, okay. By dragging meaning that you and him are having the same acceleration value. Okay, so as long as the two objects they are connected, if the object are connected, then they have the same okay, same acceleration. Alright, identify acceleration for both. Right, identify acceleration for both. Now in both case, you need to see which one has heavier mass. Alright, in this example, it seems as if M2 is larger than M1. Okay, why heavier lah maknanya? Heavier. So this one, nanti kita tengok by data lah. For instance, if this is 5 kg, then this is 10 kg. Oh, sorry, the other way around. So if this is 5 kg, then this is 10 kg. Then it makes sense that this M1 will go and accelerate upwards, while M2 will go and accelerating downwards. So this is what indicated by the two arrows here, positive and negative. Okay, now. Alright, the expression that we are going to get is by technique looking at each object. Looking at each object. For instance, looking for object number 1. Number 1, object 1. Okay. So, object number 1 is this one. So, going upward is the tension, string, and the wake is downward. So, that's the reason why tension is up. M1, because we are looking for mass number 1, mass object 1. So, M1 wait for mass number 1. Alright. And resulting an acceleration, which is force, net force, MA. However, we will be writing 1, 1. Notice that concept? And acceleration is a positive value because system M1 goes upward. So that's how we draw and then translate it into an expression. Okay, how about M2? Based on the free body diagram, okay, there's the string here. So tension would be upwards. Okay, now the same string here, if we are to draw it in this manner, you will find this version. So this one is meant for M1. This one meant for the blocks. Okay, for the blocks. Right. So Newton's third law in place here. Right. Then you will find that concept of tension says that parallel to the string and away from the object or out of the object. So that's the reason why tension is also along here. Okay, getting as such. And M2 is getting downward. So you find that we tend to write as net force equivalent to M2G. Alright, I'm gonna write it in your own version. Up, which is tension, down, M2G. Hold on. Right, so T, so this one, minus M2G is equivalent to negative M2A. M2A. So this is the expression. And then when you simplify how? In this case, they time with negative 1. But I would like to leave it, biasanya, leave it as it is. So, means that it becomes M2G. So, this is negative, become positive. Minus tension, equivalent to negative, become positive M2A. So, same as given by the book. Alright, now, so as you notice, from the two expressions, I'm going to rub this so that you can see everything once again. The book itself. So, you will find that in this expression, usually, if mass is given, so you don't have T. You don't have T, you do not have acceleration. So, two unknowns and therefore two expressions. So, two expressions, two equations to be solved simultaneously. Alright, they put here a simplified version. Can I choose not to remember? Yes, you can choose to remember. You can choose just going by the concept. It's okay. Both technique is okay. Alright, in order to understand more of this technique, what you can do on your own is you can substitute value randomly. For example, earlier I gave you 10 kilogram and 5 kilogram. Okay. Now, using first technique, this is the first technique. Okay. So, to arrive with tension and acceleration by using this first technique and double check by using the shortcut technique. Now, this above technique is for you to simulate again, okay, try again, draw free body diagram and to understand why do you arrive with this expression and calculate the tension and acceleration. And this one is just for checking mechanism. Checking the answer. Okay, checking your answer. So again, you are not constricted to 5 and 10. You can go beyond 25, 5 or just 1 and 2 kilogram to test your understanding and your mathematical skill. And by the way, do remember that, we are not going to substitute G as negative 9.8. It's just 9.81 or 9.8. Okay, without the negative. Why? Again, because negative have been included in the direction of the expressions. Alright, example 5.10, acceleration of two objects connected by a cord. Again, terms connected is referring that they have the same acceleration. Same acceleration. Okay, now, what is the situation? You have a ball, a block, so this is the ball and the blocks, okay? Attached by a lightweight cord that passes over a frictionless pulley, negligible mass. The block lies on a frictionless incline of angle such. Find magnitude of acceleration and tension in the cord. Alright, so they have the same acceleration, and also because it's the same string, same T value. Same T value, tension value. So there was just symbol T, no T1, no T2 like the traffic light. Okay, now how do we draw? Start with the simplest one. The simplest one is M1. So this is M1. Okay, now on M1, there is the weight. So M1 times G, and there's a string, therefore tension. So this is how it looks like, right? Now the drawing, now in the case of the situation here, they did mention the acceleration. Okay, the acceleration. So in this case, the acceleration is upwards. So the expression would turns out to be T up minus down M1 9.8. 9.8 or 9.81, yeah? 9.81 equivalent to M1A. Now let's say that we give them value, right? Say that this is 2 kilogram and this is 7 kilogram. So this expression can be written as 2 times 9.81 equivalent to 2A. Okay, since they have the same A, so there is no such thing as A1, A2, right? Now, you might be noticing that I'm no longer using AY, okay? Now, there's a reason for that, okay? There's a reason for that. But then again, this expression, it's arise from the concept of net force in the Y direction is equivalent to M1A, right? Okay, now then, this is the second portion where a bit tougher. Now let us look at M2, which is supposedly a bit higher level. Okay, identify what are forces. Okay, number one, tension. Number two, weight vertically downwards. So what is the object? M2. So M2G. Since I did mention that it's 7 kilograms, so perhaps you can just write it as 7G. Okay, 7G. And since there is a surface here, so we have another which would be normal force. Okay, normal force. So Tn and 7G or M2. So 1, 2, and 3. Okay, now, however, why did it open to the component? Because the acceleration. It's because of the acceleration, because of the motion. Acceleration is occurring here. Since it's occurring along the incline, then you can assume that the incline is the x component. Okay, the x component. And perpendicular to the incline is the y component. So such and such. Alright. And then, okay, since we are interested to write down the expression, okay, write down the expression in the x direction, okay, this is the expression, okay, in the x direction. So we tend to write on the right force, okay, what is this? It's originate from mass wake number 2. So the nearest x component, so the nearest, this is the main, okay, this is the main, open to the nearest and the nearest. The nearest x will be mg sin theta and this one is mg cos theta. Madam, I'm a bit lost why that we are using theta here. Okay, let's say lah, this expression is 30 degree and theta, yeah. Now, if this is 30 degree, okay, 30 degree, then it makes sense that this is 60 degree. If this is 60 degree, then this is the same as this one, 30 degree. So that's 30 degree just now. So theta. So remember the tips earlier in our class that if your vector touch with the hypotenuse, okay, touch, angle, sorry, vector of interest, and the angle that you are about to use is touching, then it becomes cos. And this one would be sine. Alright. So it's almost like writing it something like this. Wake number 2, sine theta. And this one is wake mass number 2, cos theta. Alright, motion occurring in this direction. And therefore, we are going to, okay, to get the direction of the arrow as a positive value because it's almost to the right but it's just a bit tilted to the bottom, kan, macam sengit ke arah bawah tapi it's to the right. So we are going to assume that this is a positive value and this is the negative value, and hence it will be m2g sin theta minus t. Why? Because opposite in direction. Let's look again at the answer. m2g sin theta minus t equivalent to m2a. Now, put positive or negative because acceleration occurring similar direction, okay, as m2g, and we just mentioned earlier that we are going to consider this as a positive value, and that's the reason why you have equivalent to a positive MA. Positive MA, and in this case because we are referring to object number 2, mass 2, and that's the reason why M2A. And observe the A. It's just A here and it's just A here to represent that they have the same value. So their symbols should be same. And since symbols, there is no, notice here, it's Y, but here they are disappearing it to indicate that this A, and this A is of the same thing, So we do not want to include AY just now or else we get confused. Okay, the symbol bear the same value and the same goes as the tension just now. Same value as this expression. Now that you see here, okay, after this you are going to simplify and get the A and T. However, do you need to memorize this? No need. It's actually enough understanding the process of getting the expression. First, master how to draw free body diagram, and from free body diagram, get the expression. Should be ample. Now, this is example 4.7 is not from your textbook. However, we are going to use it as an additional example to let us understand more on how to draw free body diagram and finally solve. Now, in this example, the thing that you need to note is, okay, it would be A0. Acceleration would be 0. Why? Because the system is in equilibrium. So the case is there is this sled. It's tied to a tree on a frictionless, there's no friction, snow-covered hill. If the weight of the sled is 77 Newton, find magnitudes of the tension. So they want tension, number 1, and the normal force value, okay, exerted by the heel on the sled. Alright, now, free body diagram. Start with a string. So that is a tension. Then wake, common all those common things. So wake is just now 77 Newton. So 7 Newton. Finally, the direction of the normal force. Why there is a normal force? Because there is a surface and the surface is being pressed on. Okay, so this is the direction of normal force. Okay, let's double check with given. Normal force, string tension, and then wake. Alright. Now, since our interested force, tension and normal force, okay, is somewhere here, okay, you will find that you would like to only assess forces in this direction along the incline and also perpendicular to the incline, because the understanding is that is where normal force and tension lies. Okay, that is di mana normal force dengan tension berada. So itu sebab kita nak lihat in this direction. Okay, therefore same as the technique used earlier, we are going to put it as if the incline is the x direction, and perpendicular to the incline would be the y direction. And we find that, oh, normal force overlap with y direction, tension overlap in the x direction. Except this one. Except wake. Alright. So, what we need to do is, this is the axis just now. We are going to open the component. So, the nearest y and the nearest x. And that's the reason why it's in this direction. Okay, this is the resultant just now. Wake is the resultant. So this would be jotted down mg cos theta, and this one would be mg sin theta. Now, the only thing that you need to add on is, okay, now put your hand similar as this figure. So this is your right hand. This is your left hand. So in that sense, you would say that this is positive and this is negative. And that's the reason why this is negative just now, to indicate and strongly emphasize on the direction. And it goes the same with mg cos theta to indicate the direction. Okay, even if it's not here, it's okay. It's just that this is put here to show the direction to the student. Alright, therefore, from the free body diagram, let's now, the object is just this object. We are not interested with the tree. We are just interested with the sled. Or this wall memang dia bagi pun mass sled. Jadi, object of interest is sled. Alright, so in the x direction, what are forces along it? There are two. Number one, okay, saya bulatkan. What are forces? Okay, this is my question. What are forces in the x direction? Number 1 and number 2. Therefore, becomes to the right t minus mg sin theta. Okay, again repeat. Why negative? Because we are now making as if. Okay, repeat. Your hand, okay, dempangkan tangan, open wide your arms. Your right hand point in the same direction as the tension, slightly tilted up, while mg sin theta tilted downward by your left hand. Maknanya tangan kanan awak arah sama dengan T, tangan kiri awak mg sin theta. And T is directed to the right. And therefore, that's the reason why T is a positive value, mg sin theta is a negative value. And then substitute the angle, then you can solve the value of the tension. Solve one value. Alright. Then look at the y direction, because the normal force lies in the y direction. So kita lihat matematik dia. The mathematics based on this figure. Number 1 is normal force. Number 2 is mg cos theta. So, matematik dia ini atas, above, di bawah. Okay, so that's the reason why positive normal force minus mg cos theta. And again, nampak ya, that in your calculation, when you measure weight, dia tak jadi negative 77 because negative is already here in form of direction. In form of direction. So jangan overdo it. 2 kali pula. So solve, you are going to get the answer. Okay, give a try to this question. Overall, this question is talking about number 1, acceleration is 0. Number 2 adalah redefining balik, set balik arah X component and Y component. Okay, cuma kita mimikkan tangan kita similar as in the figure. Okay, thank you very much. That's all. Perhaps as an exercise, you can give a try to this question whereby a child climbs onto it and then tension now is a given number. So your question to be asked, to be answered is, what will be the weight of the child and the normal force? Thank you.